Hello, I am Humam Al-Wasal, and I'm happy to share our work on temporally sensitive pre-training. State-of-the-art localization algorithms rely on video encoders that were pre-trained on trimmed action classification, or TAC. However, TAC pre-trained encoders are temporally insensitive for untrimmed videos. They produce high similarities between features of background and foreground clips of the same video. We show here the cosine similarities between TAC clip features for two videos. The green lines show the extent of action instances. Notice the high similarities between foreground and background features highlighted in blue. This temporal insensitivity is suboptimal for localization tasks. Thus, in our work, we propose TSP, a new pre-training strategy to make video encoders temporally sensitive. Given an untrimmed video, we sample a short clip and generate its local clip features. We aggregate the local clip features across the video to create a global video feature. We pre-train the encoder on two classification heads. The action label classification head predicts the activity class from the sampled clip if the clip is from a foreground segment. The temporal region classification head takes in the concatenation of local and global features and predicts whether the sampled clip is from a foreground or a background region. We study the effects of our TSP pre-training on three major localization tasks: TAL, proposals, and dense captioning. We evaluate our approach by training state-of-the-art localization algorithms on top of our TSP features. Note that we do not innovate in any of these algorithms or change any of their hyperparameters. We simply just swap the features they use with TSP features. We design our ablation studies to examine the generalizability of TSP on 4 dimensions, across different target localization tasks, using different encoder architectures, with different localization algorithms, and pre-training datasets. We compare against 3 TAC pre-training baselines: TAC on kinetics, on ActivityNet, and on Thomas 14. In the study, we examine TSP on different tasks. Specifically, we pre-train our 2+1D34 on ActivityNet and use GTAD, BMN, and BMT as the algorithms for TAL, proposal, and dense captionings, respectively. The gray columns highlight the main evaluation metrics of each task. We observe that TSP features significantly outperform the 2 TAC-based features on all tasks. This highlights the importance of temporal sensitive features for localization tasks. In study 2, our goal is to test if TSP generalizes to different encoders. Specifically, we pre-train 3 different architectures and then test them on the ActivityNet TAL task using GTAD algorithm. We observe that TSP significantly outperforms TAC baselines for every encoder. Additionally, we observe that the performance gap with TAC features increase with the deeper encoders. This suggests that the performance of TSP features scales better with the size of the encoder. In the study, we examine if the TSP features are effective regardless of the localization algorithm we use. Specifically, we repeat the same experiment of study 1 for the TAL on ActivityNet and use BMN algorithm instead of GTAD. The results show that TSP features are the best with BMN as well. In the study, we examine if TSP features transfer across datasets. Specifically, we pre-train on ActivityNet and pre-train on Thomas 14. We test the resulting features on the Thomas 14 TAL task using PGCN and GTAD. We observe that TSP on Thomas 14 outperforms TAC baselines. Interestingly, TSP on ActivityNet outperforms TAC on kinetics. This shows that TSP is transferable across datasets. The TSP features push the state-of-the-art on TAL on ActivityNet and Thomas 14. TSP is competitive in proposals and achieves state-of-the-art in dense captioning in terms of the blue metric. We use the DETAD analysis to understand the TAL performance as a function of the action instance length. We observe that TSP performs significantly better on the extra short and short actions. Note that the extra short and short actions make up around 70% of all actions in ActivityNet. The temporal sensitivity of our features allow localization algorithms to draw sharper boundaries and detect shorter actions better. Here we analyze the similarities between clip features of the same video for both TAC on kinetics and TSP on ActivityNet. In A, TSP differentiates foreground from background clips. In B, TSP learns to homogenize the similarities between action features. In C, TSP increases the differences between background and foreground features. And in D, TSP learns dissimilarities between the foreground and background. Please take a look at our project website. We have released the code, pre-trained models, and features. Thank you.